Okay, so this video is still for chapter 11, but we're going to do confidence intervals this time. So when we do hypothesis testing, when we have a guess as to what the population is going to be, we do confidence intervals when we don't even have a guess. That's how bad we're doing. But we want to build a confidence interval around it. What does that mean? What it means is that I don't know what mu, the population mean, is, but based on the information I have from my sample, I can say mu is between, I don't know, any number, 50, and I don't know, 39. It would depend definitely on the sample. This is just an example. So it's just a different way of guesstimating, of doing statistics, and it definitely gives us different information in hypothesis testing. Because remember, for the problems for hypothesis testing, we knew what the population mean was. Like, the problem would always give us this number. For confidence intervals, our formula is just building an interval around what the population mean is. So let's look at this formula. So this little s of x is basically the standard error. And it represents this, the sample, standard deviation. Let me erase this little arrow so you don't get confused. And the samples, the square root of the sample size. This is what we're going to get from the table, from the t-table. Notice how on this side it's negative and on this side it's actually positive. So in this case, we're going to use the table. We're going to use the table the same way we did before. It's just, it's always going to be plus minus because we want to build the interval, and a value has to be above the mean and a value has to be below the mean. That's usually what intervals are. Okay. And this value, this symbol, I'm sorry, represents the sample mean. And notice it's also here. So actually, the only difference in this formula here and here is just this symbol. That's the only thing that changes. It's the same formula on either side of the population mean. Pop mean. Okay. Degrees of freedom are going to be the same as before, just n minus 1. So this is the formula that the textbook, the Heyman textbook, recommended, this one. But I made it simpler just because I like simpler things. I'm a simple person. So what I did is I substituted the standard error by using this little equation. So I just put the sample standard deviation here, the sample size. This is the same t value, t critical, that we're going to get from the table, and this is the sample mean. So it's the same thing. I just substituted this into here. And this is what I'm going to give you on the test, so you should be okay. This part of the equation, this part of the equation, and same over here, this part of the equation, we call it the margin of error. And what the margin of error tells you is just how far away you are from the sample mean, above and below the sample mean, basically. It just tells us how far away we are. Just in case you see the word somewhere, that's what that means. A point estimate is a specific value of a parameter. What does that mean? So, for example, in this chapter, I won't know what mu is. Have a big question mark. I don't know what it is, but the best point estimate of what mu is going to be the sample mean. You can think about best point estimates outside of best guess. In the same way, we're not going to cover this type of interval because mostly we focus on the mean. But for example, if I didn't know what the population standard deviation was, my best guess as to what that's going to be is going to be the sample standard deviation, and so on. For example, for the correlation, this is the symbol for the population correlation. So my best guess as to what the population correlation is, or in other words, the best point estimate as to what the population correlation is, would be the sample correlation, which is the one that we are familiar with. Okay. So what are we doing when we do confidence intervals? So for example, here I have many samples. I have the sample mean, and the person who created this table created 20 confidence intervals around the population mean. So if we say the population mean is 61 from here, that's mu. This confidence interval, that's capturing 61. This one, same. Let me use a different color. So this one, yes. This one, yes. This one, yes. So what I'm looking for is that the interval is capturing this. What I mean by capturing is that between 57.06, mu is between 57.06 and 63.85. And we know in this example, we know that mu is 61. We assumed it was that. So yeah, my confidence interval is working right there. It actually, out of this 20, it seems like only one of them does not capture the population mean, and it almost did. It started at 61.33 to 66.13. So yeah, we didn't capture. So in this example, we were doing a 95% confidence interval. So that means that 5% of the time we're going to fail to capture what the true population mean is, which in this case is 61. So 5% of the time, that's also coming from the alpha that we use in hypothesis testing. Except here we represent it as 95. So 95%, we are pretty confident that the confidence interval that we created is going to capture the population mean. 5% of the time, we could be incorrect. And we're okay with that 5%. At least psychologists are okay with using 5%. Other sciences may use different alphas. Okay, and it's the same idea here. So 95% of the time, you can see my intervals are capturing the population mean. So this one is capturing it. All of them are capturing it, because that line is my population mean, except for this one. This one is not capturing the population mean. So that's my 5%, basically. 5% of the time, I do not capture that population mean. So long you're not building a bridge, developing something that may cause harm, 5% is okay. Okay, let's actually do a problem. 10 randomly selected people. So this is our sample size. So I know that n is 10. That is a big hint that I need to use the t-distribution. Because you could do a confidence interval for the normal distribution. That is possible. It's just we don't cover it. The mean time was 7.1. So here you need to ask yourself, is this the sample mean or is this the population mean? And it's actually from the sample. Remember, for this type of problem, we don't know what mu is. That's actually the question. What is mu? What we're trying to develop, what we're doing with this whole problem is creating an interval around that mean. In other words, if I was doing consulting, I would say, I would say to my client, I don't know what the population mean is, but I can tell you is between this number, 29, and this number, 35. So that's what we're doing, but we're doing it based on the data for this example. So x bar is 7.1, and the sample standard deviation, that is 0.78. This looks a little ugly. My degrees of freedom are going to be 10 minus 1. That's 9. So my T critical, I'm going to go to my fabulous table. I could not get this table to open anywhere else, so I had to use Explorer. Ew. Okay. My degrees of freedom was 9, I believe. Oops. Yeah. And what you need to know about this table is that it's weird, and it has confidence intervals at the bottom. So that's going to change from when we're doing hypothesis testing. We have to use the numbers at the bottom. So I want it to be, I think, 95% confident. And my degrees of freedom were 9. So I'm going to go this way, and then I'm going to go this way. So my T critical is going to be 2.262. So, and remember, it's going to be negative and positive. Cool. So 0.78 square root 10. Negative 2.262 plus x bar, which is 7.1. Every time I teach this, apparently it doesn't matter the format, I always run out of space. So 0.78 square root of 10 plus 2.262 plus x bar, which is 7.1. I'm going to pause the video so I can rewrite this. Okay, using the magic of television, I just rewrote the equation. You know what my biggest fear teaching online is going to be? That I don't have you guys to tell me if I write the wrong number, which I tend to do all the time. But okay, we'll survive. So this part of the equation is the margin of error, like over here. Let me actually write the name margin of error. Cool. So I recommend you calculate this part first. Okay, so I'm going to start with parentheses. 0.78 divided by the square root of 10. I would close the parentheses here, parentheses, negative 2.262. I hesitated because I don't really know how to use this calculator. We'll see what we get. And that is my margin of error. I'm going to round that just for fun. I'm not picky with my rounding, so don't worry. My margin of error would be 0.56. And I believe it was negative. Yep. And then I have mu. I don't have mu. I have plus 7.1 mu positive 0.56. You don't have to put the positive. I'm just doing it because I'm showing you how to do this. So now this part is the margin of error. This section is the margin of error. There you go. Scrolling down a little bit. And then you just do this operation, point that plus 7.1, 6.54, and that's on one side. Yeah. And then on this side, we just add them together, and I believe is 7.66. And this is it. This is my confidence interval. Okay, so this is what our confidence interval is. We're happy. What this means is that we are 95% confident that, oops. So we still need to interpret what our confidence interval is. So we are 95% confident. And I say 95 because this is what they asked of us. We were using 95. So we are 95% confident that okay, let's do our first confidence interval problem. So 10 randomly selected people. So the fact that that's our sample size. The fact that it's so small, small being less than 30, should tell us that we should be using the t-distribution. If it was greater than 30, then we would be using the normal distribution. Let's keep reading this. The mean time was 7.1. So it's a mean. You need to ask yourselves, is it a sample mean or is it a population mean? So spoiler alert, it's always going to be the sample mean, because remember, for confidence interval, we don't know what the population mean is. Actually, the whole reason we're doing this problem is so we can guesstimate what the population mean is going to be. The sample standard deviation S was 7.78. So 0.78. I'm going to say X bar is 7.1. My degrees of freedom are going to be 10 minus 1. So let me go to my fabulous table. So what you need to know when you're doing confidence interval is that you're going to use the bottom of the t-table now, where it says confident level. Let me go back to the problem. So you need to determine what confidence level you're going to use, and it's right here. It is 95% confidence. There you go. Back to the table. So 95% confidence, that's there. My degrees of freedom, I believe, were 9. So I'm going to go this way. Oh, wow, my pulse is not great, but I'm pretty sure you know that. There it is. That's my t-critical. So my t-critical is 2.262. Cool. So remember, this is on this side is going to be negative, and on this side is going to be positive. So I'm going to start plugging in things. 0.79 square root of 10. My t-critical is negative 2.262 plus 7.1 mu. And then the same thing, 0.78 square root of 10 plus, that's the only thing that changes, 2.262 plus 7.1. Let me try something. Okay, maybe not. Forget it. Okay, let's actually do a problem for confidence intervals. Sleeping time. So 10 randomly selected people. That 10 is actually our sample size. And the fact that it's so small, and by small I mean less than 30, that tells us we're going to use a t-distribution. Okay, the mean time is 7.1. So that's a mean, cool. I need to know if it's the sample mean or the population mean. And spoiler alert, it's always going to be the sample mean, because the whole goal of doing a confidence interval is that we don't know what the population mean is. We're creating an interval around it. And then we keep reading. Sample standard deviation was 0.78. So this should just be S. Just S. Cool. 0.78. X bar is 7.1. My degrees of freedom are going to be 9. To find my t critical, so this part of the equation, I need to use my table. I'm going to erase this like I hadn't recorded this problem 100 times. So for the t table, you need to use the bottom of the table where it says confidence level. For our problem, it's going to be 95%. Let me show you where I got that. Oops, wrong. So I know it's a 95% confidence interval because it's right there. So I go to the column where it says 95, and then I go to my degrees of freedom, which are 9. My pulse is not very good, but I'm pretty sure you all knew that. So here is my T critical. There you go. So 0.78. Oof. 0.78 square root of 10. My T critical was 2.262. So here's going to be negative 2.262 plus the sample mean, which is 7.1. 7.1. Mu 0.78 square root of 10, 2.262 plus 7.1. Make that prettier. 7.1. Okay, notice that this is negative, and this one, it's an implied positive. So this part of the equation, this part of the equation up to here, and this part of the equation is what we call the margin of error. Okay, and that's the first thing we're going to calculate. Let me go to a calculator over here. Cool. Let's do just the margin of error. So parentheses. Parentheses are your best friends. 0.78 divided by the square root of 10, close parenthesis. multiplied by negative 2.262. So cool, 0.557. And I believe it was negative, plus 7.1 mu positive 0.5 plus 7.1. Okay, so this part, it's the margin of error. This part is also the margin of error. Okay. So all we have to do now is just do this number plus 7.1. 6.4. I think my biggest fear is I'm going to make a mistake in a number, and I don't have you guys to tell me that I made a mistake on the number. 7.66. Okay, so that's it. That's our confidence interval. It's not that hard. It's not hard. Okay, so now we just need to interpret. And that's what we're going to do. So we are 95% confident, because we're doing confidence intervals, that the population mean is between 6.54 and 7.66 hours. Cool. Let's do another problem. So 10 randomly selected cars, that's our N. My degrees of freedom are going to be 9 again. Blah, 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 blah. Sample mean was 0.32, so that goes here. And the standard deviation of the sample, that's our S, 0.08. And we need to find a 90% confidence interval. So the next thing I need to find out is my T critical. For that, I need my table. Again, remember we're going to use the bottom of the table. Cool. It's not erasing. So now I need to look at the 90% column and 9 degrees of freedom. Maybe I shouldn't have erased that one, not that I think about this. Okay, 1.833. .833. There you go. So remember, it's going to be negative here and positive here. Let's do this. 0.08 square root of 10 multiplied by negative 1.833 plus the mean, which is 0.32, mu, also mu. So 0.08 square root of 10, 1.833. I don't think I'm going to make it fit, plus 0.32. No, cool. Okay, again, this part is what we call the margin of error. Okay, so that's what we're going to calculate first. And I recommend you do this because otherwise, Well, if you have trouble with the order of operations, I recommend you do the margin of error first, and then you do the rest of the confidence interval. If you're feeling pretty confident about it, then you can just go ahead and do the whole thing. Okay, so it's going to be parentheses 0.08 divided by the square root of 10, parentheses, times negative 1.833. Negative 0.04, that's small. So negative 0.04 plus 0.32 mu 0.04 positive plus 0.32. So now you just do this operation, and according to me I got 0.28, 0.36. So this is my confidence interval. Now I just need to interpret. So we are, in this case, 90% confident that the population mean of what? The population mean of threat width. Okay. Threat width is between 0.28 and 0.36 inches. Punto. That's it. That's our second problem. And my recording has not falling apart, so that's always good. Let's do another one. So a sample of 17 states. Nice. So that's my sample. Then I keep reading, and it says that the mean cigarette tax again. Well, this one is clear because it actually says sample mean. So I know it's X bar. Then I keep reading, and that should not be there. S is actually 38.37. So I changed some of the notation. That's why you sometimes see S of X, but it should just be X, unless it's S of sub X bar. That's actually representing the standard error. Okay, my degrees of freedom are going to be 17 minus 1, 16. To find T critical, I need to go to my fabulous T table and erase stuff. So again, look at the bottom, confidence level. So I wasn't paying attention, obviously, and I don't know how confident I want to be. I want to be 98% confident. Let's see if I can be 98% confident. Yep, there it is. And I have a 16 degrees of freedom, I believe. Yep. So 16. $2.583. I'm gonna forget that by the time this loads. 2.583. Okay, so let's plug it into the equation. 38.37 divided by the square root of 17. 2.583. So here I forgot something, and what I forgot was the minus. Yeah. Okay, plus 91.06 mu square root of 17 times 2.583 plus 91.06. There's a period there, a decimal, sorry. Okay, so again, this is the margin of error. So I'm going to calculate that part first. Clear, so parentheses, 38.37 divided by the square root of 17, parentheses, times, I would recommend also putting parentheses here. I know I didn't do it last time, but I recommend it. Do as they say and not as I do. So that's it, 24.03. That's my margin of error. So I forgot the negative here. 24.03 plus 91.06. And then we just do plus 91.06. And then on the other side, we just add them. So 67.02, 115.09. So that's my confidence interval. Now I just need to write my conclusion. So we are 98% confident that the population mean of cigarette tax, I don't think I know how to spell cigarette. I'm just gonna let it go. Cigarette tax is between 67.02 and 115.09. I think it's the unit is cents. Yep, it is cents. So that's it. That's the conclusion. Okay, one last problem. And it's probably the hardest. Oh, wait, no, it's not the hardest. This shouldn't be too bad. So we have a group of 20 students here. That's our N. They have a sample mean heart rate of 96, so 96, and a standard deviation of 5. Cool. And we want to be 99% confident. So my degrees of freedom are going to be 19. My T critical, I want to be 99. And my T critical is going to be 19. There you go. My T critical is 2.861. So I do my best to make this fit here. Square root of 20 multiplied by negative 2.861 plus 96 multiplied by positive 2.861 plus 96. Again, we calculate the margin of error first, and it's the same on both sides. And magic of television, according to me, the margin of errors was 3.19 negative on this side plus 96. On the other side is going to be positive 3.19 plus 96. The actual interval is 92.80. $99.19. So the conclusion is that we are, oh, that looks ugly. We are 99% confident that the population mean of heartbeats is between, and this is a situation where I would round just because 92.80 of a heartbeat doesn't make a lot of sense. 93 and 99 beats per minute. That's it. That's our conclusion. Let's go to the next problem. At least now you have the advantage that if I'm going really fast, you can pause me. Okay, so here it is. Home fire started by candles. Cool. Really, the only information I got from here is that they want a 99% interval. So here we have the raw data. So we actually have to find the mean and the standard deviation by ourselves, which is honestly annoying. So I already gave you the x's and I already squared them for you. Again, I'm going to say this in every video. Whenever you square a negative number, it becomes positive. I don't care what your calculator says. It should be positive. Here we don't have that problem because they're all positive, but you may encounter that later. Okay, so I just need to add this column. So for 54 plus 59 plus 60 plus 63 plus 71 plus 84, and that gives me 391. When I add and remember, that's what this symbol tells you, that you need to add. When I add the second column, I get a giant number, 26,6063. Okay, so I need to find what my n is, what my s is, and what my x bar is. So my n is 1, 2, 3, 4, 5, 6. Next, I'm going to find my x bar because that's easier. So I can do 54 plus 59 plus 60 plus 63 plus 71 plus 84 over n, which is 6. Or I could have just done 391 over 6. And my x bar is going to be 65.6. 17. Next, I'm going to find my standard deviation, so 65.17. My standard deviation, but remember, before I even find the standard deviation, I have to find the sample variance. This is chapter 5, I believe. So remember, you're always going to put the largest number first. So 26,063 minus 391, but we have to square it, divided by 6 over 6 minus 1. I hope I have some space here. I recommend doing this part first, and that is going to get us 26,063 minus 25,480.16 divided by 5. Cool. I do this subtraction next, and that gets me this number, 582.83, and then I still have to divide by 5. And when I do that, I got 116.56. So remember, this is S squared, so it's the sample variance. To find the sample standard deviation, what I have to do is take the square root of 116.56, and this is going to be S. When I do that, I got 10.8, and this is the sample standard deviation. So I need this number, I need this number, and I need this number, the 6. S is 10.8. There you go. So I have to write them here again. Let me change my color. How about, let's do pink. Why not? So N was 6. My S is 10.8. My degrees of freedom is going to be 5. I need to go to my fabulous table. Well, this is going to be complicated. Well, I want to be how confident? 99. So 99% confident. My degrees of freedom are going to be 5. Nice. Looks like that's going to be my confidence, my T critical, sorry. 4.032. Oh yeah, completely spaced out. Okay, so let's do this. 10.8 divided by the square root of 6 multiplied by negative 0.4032 plus x bar. X bar is 65.17. 65.17 mu 10.8 over square root of 6 positive 4.032 plus 65.17. Okay, let's do the margin of error first. And that is going to be a value negative 17.7 plus 65.17. Here on this side is positive 17.77 plus 65.17, and then you just do the addition on this side, on either side, and I got 47.2 39. And on this side, I got 82.94. So we are 99% confident that the population mean of, is it home fires? Yeah, home fires started by candles is between 47.39 and 82.94 fires, I believe the unit. That's a lot of fires. Just don't use candles. I think this is the last problem for chapter 11. I will be working on the next video.